we want to talk about Python programming modules and packages. There are modules and packages that has been installed already in Python, and I have a reference. You can get more reference on this link. There are two types of modules in Python. We have the built-in modules. The built-in modules are already installed on Python immediately as soon as you install your Python or Anaconda, in Python Anaconda, those modules are already there. And the other one is the user-defined modules, or we call it built-in modules, that you yourself can build yourself and you can make use of. I think we've made use of one of them in the control flow statement. So we've used that. And so let's talk about some commonly used Python built-in packages. Number one of them is what is called the NumPy. And I will send this to you so that you can read more about NumPy. NumPy traditionally is used for scientific applications. The word NumPy is from number Python, and they are basically used for mathematical and scientific applications. Like I said, traditionally we start our list with libraries for scientific applications. NumPy is one of the principal packages in this area. It is intended for processing large multidimensional arrays matrix. You know what is called an array and matrix? So that is what NumPy is used for. We are going to work on each of them extensively. An extensive collection of high-level mathematical functions. So in this NumPy package, there are a lot of high-level modules packaged in NumPy that are for mathematical functions. An implemented method makes it possible to perform various operations with this object. So there has been a lot of improvement that has been made on the library. So this is one of the mostly used package in Python, and people make use of this a lot because it has to, you can use it for scientific application and mathematical functions a lot. So in addition to bug fixes and compatibility issue, the crucial change regards styling possible printing format of NumPy object. Some function can now handle files of any encoding that is available in Python. So there has been a kind of modification, and the current versions can handle a lot of files in different formats. So NumPy are basically for scientific applications, for high-level mathematical functions of either an array or matrix. By the time we take this NumPy separately, we are going to talk in detail what exactly is multidimensional arrays and multidimensional matrix. So you can go to this link and read more about NumPy package in Python. Another one is called the SciPy. The word SciPy is scientific Python, and is another core library for scientific computing. It is for scientific computing. It is based on NumPy and therefore extends its capability. So this SciPy is like an additional step ahead of NumPy. It goes in depth into scientific computing more than NumPy. You understand? So a NumPy SciPy main data structure is again a multidimensional array, just like NumPy. It's also work on multidimensional array, but the difference between this and NumPy is more like a scientific upgraded version of NumPy. So the package contains tools that help with solving linear algebra, an advanced level of mathematics, probability theory, integral calculus, and many more tasks. So SciPy faced major building improvement in the form of continuous integration into different operating systems, new functions, and methods. So it is an updated version of NumPy that has been extended to cover more scientific calculation, linear algebra, probability, calculus, and the rest. So these are also an important package. And in Python, if most of them are also installed in Python, yes. So these are called inbuilt packages or inbuilt packages, yes, in Python. They are inbuilt. They are already on the Python, on the Anaconda or Python programming language. All you just need to do is to install, and you import them anytime you want to use them. Another important Python program package is the pandas. Panda is a Python library that provides high-level data structure. We are going to take, time permits, we are going to take many of these individually. These are things that you spend like 1 or 2 days looking at them individually. So the pandas is a Python library that provides high-level data structure. For example, if you want to analyze data collection from, okay, how many people buy, for example, people that they are doing, how many people buy product from Amazon, how many people buy product from maybe eBay, how many people buy product from Shopify, and the rest. You want to do a kind of data analysis. The best application for the Python package for that is Pandas, because it handles a lot of high-level data structure and a vast varieties of tools for analysis. So great features of this package is the ability to translate rather complex operations with data into 1 or 2 commands. Pandas contain many built-in methods for grouping, filtering, combining data, as well as time series functionalities. So that's another function. So I also put a URL here where you can read more about pandas, and you can see some other work you can do with pandas. Another package that is also important is the matplotlib. The matplotlib is a low-level library for creating 2-dimensional diagram and graphs. This is basically for plotting of graphs. Yes, with the help of Matplotlib, you can build diverse charts from histogram, scatter plot, non-Cartesian coordinate graph, and many popular plotting libraries are designed to work in conjunction with Matplotlib. Yes, many plot libraries are already built to work with. So anytime you want to do graph, you want to plot graph, you want to talk of anything that has to do with plotting, the best package on Python to do that is Matplotlib. Of course, you can also use it in conjunction with other popular plotting libraries, but which can also work with Matplotlib. So there have been style changes in color. You can input color, you can input font, legend, and many more. So as an example of an appearance improvement are automatic alignment of artist legend and among significant color improvement. So you can maybe want to plot the graph of the boys against girls. You can assign different color, you can put different legend. Instead of using the traditional Excel for plotting, you can use Matplotlib on Python to do some of this work. Another package is the scikit-learn. The scikit-learn module is like a combination of the NumPy and SciPy, and it's one of the best libraries for working with data. So they use it for working with data for machine learning, regression analysis, and the rest. It provides algorithms for many standard machine learning and data mining tasks. When you want to do data mining and machine learning, clustering and regression, classification, dimensionality reduction, and model selection. All these things, you may not understand them now, but I'm telling you, this is an advanced level of Python programming application. But that it will be nice if you know them, but it is better we cover the rudiments now, the basis now before we move to that level. So this scikit-pan is more advanced for machine learning, data mining, and clustering, regression analysis, and classification. So there is a number of enhancements made to the library. Like I said, it's an advanced level of NumPy and SciPy combined together. So the cross validation has been modified, providing an ability to use more than one matrix. You can work with this with more than one matrix, several training methods like nearest neighbors and logistic regression, and many more that you can do with SciPy. So if you are interested in learning more about scikit-learn, you can also go to this URL address to learn more. And another one is the TensorFlow. TensorFlow is a popular framework for deep and machine learning. These are advanced level of Python, deep and machine learning. It is developed in Google Brain. So these are packages that are used for advanced level of data analysis or machine learning analysis, like facial recognition, like identifying a picture. Okay, if you want to, for example, if you show the face of a particular dog to machine learning, they can tell you, okay, this dog is Babu, this dog is Pitbull, this dog is Rottweiler or anything. Or you show a picture of a car to someone, to machine learning algorithm, it will tell you, okay, this car you are showing me is Ford Escape, is Ford what is it? Escape or Escort, or is Toyota Camry is this. So all these TensorFlow are used for advanced level of deep learning and machine learning calculation, and there are also different layer helpers on top of regular TensorFlow, such as TFLN, TFSlim, skflow, etc. So these are, and it was designed, I think it was designed by Google, a Google scientist. Yes, by Google. So the other one is the TensorFlow Keras, which is more advanced, on top of TensorFlow. It is a high-level library for working with neural networks. You may not understand the neural networks now. It's for deep learning, and they are used for advanced artificial intelligence work. So these are numerous type of, they are inbuilt. They are already built and they've been already installed in Python. All you just need to do is just for you to call them out of library time you want to use them. And we also have what is called the user-defined modules. The modules which the user define or create are called user-defined. You are the one that define your own module in this case. So they are user-defined modules. They are not installed in Python. You are the one that will define it yourself. You define it yourself. Once you define it yourself, then you can make use of it. And anytime you want to use them, you have to define them again, because they are not inbuilt, like the TensorFlow, the Pandas, the NumPy, the Scikit, the Scikit-Py that we talk about. So let's just work with one or few of them. Let's work with Python, with Pandas rather. Pandas is a package that is used for data analysis. And when you want to work with those inbuilt packages, the first thing is to install them on Python. You install them. Let me show you how to install Pandas. You can go to your Anaconda like this. When you come to an Anaconda, if you look at my screen, I have installed. These are the installed packages that I have on my Anaconda. The same thing are also applicable to yours. There are a lot of packages that has been installed. However, if you also see, there are non-installed packages. All these ones are not installed because I'm not working with them now. So if I'm doing a work that requires me to use, maybe for example, this particular one, I will have to come here and install it. One of the easiest way we can install using a command script, but one of the easiest way to install package on Python is to come to this place and install. For example, now let me put it to all. That means it both installed and uninstalled. Let's say, for example, I want to install Pandas. I'm sure I've installed Pandas here. Let's say, just come, if you just know the name of the package you want to install. Let's put Pandas and search. Can you see? As soon as I put Pandas, I have numerous level of Pandas, numerous type of Pandas. You see this one? Pandas, high performance, easy to use data structure and data analysis tool. It is for data structure and analysis. So now let's assume I've already installed this. I want to install this Pandas Alive. Now, I've already installed Pandas. That's why, but I want to use another package that I've not installed. Let's say I want to install this pandas alive. All you need to do is click on it, on this pandas alive. Once you click on it, it will display here. Do you want to apply or you want to clear? But because I want to install, just click apply. It will show you this box face install packages. It will install the packages that are present under this. It will install this package. Every other functions that are present under this package, it will automatically install them. Although it may take you few minutes, it will take some minutes to finish, but that is one of the best way to install package. So if you don't have pandas on your own, on your Anaconda notebook, you can come to this place, do that, and install. Let's go back to, so because if you do not install pandas, you won't be able to import pandas. So now, when you want to work with a package on Python, after you have installed the package is already stored in your library. So anytime you want to work with that package, you have to import the package from library for you to be able to use it. Even though I have installed pandas and I want to work with it now, the first thing I'm supposed to do is to import this, so that just like you have a textbook already in your library, right? And you want to read that textbook. It is common sense for you to go to the library and take out the textbook. You can't say because the book is already in the library, then the book is there, you are reading it. No, you have to go to the library, take out the book from the library and read and make use. So even though you already installed the pandas, whatever packages you are working on your Anaconda on your notebook, it is now good for you to go and import it from the library anytime you want to use it. And to import a library in Python, just type import, just put import the package. Just import and the name of the package. If I want to import SciPy, import SciPy, import TensorFlow. You understand? Now, for conveniency, when you are writing your code, so that you will not be typing pandas every time, you can now tell this laptop import pandas as PD. Just give it a short name. You can call it P. You can call it PDS. But just to make it for a short form of it, you call it PD, import pandas. You understand? And once you do that, I think let me separate this command. Now, import pandas. Once you import it, just run it. I've done this now. This is already done. So that means automatically I've imported pandas from my library to my workspace now, so I can use it now. That's fine. Now, when you are working with pandas, you are working with data. Let me, for example, look, this is a data of people that traveled in Europe, for example. So travelers that went for summer holiday in Europe, they took their movement. So they want to know, okay, people that traveled in Europe for this summer, where do they visit most? Did they visit United Kingdom? Is it Spain? Is it Holland or Germany? So they took their information. They took their latitude of the location, the longitude of the location, the date, the city, and the country that they visited. So just like they may want to ask, somebody can send you a data too, as a scientist, that okay, these are the data we collected. Maybe the number of people that came to campus. okay, maybe to the museum. Okay, how many people came to the museum throughout in 1 year? How many of them visited maybe to the zoo? Let me use the zoo as example. How many people came to the zoo in 1 year? How many of them visited the lion cage? How many visited the tiger cage? How many visited the monkey cage? How many visited the giraffe cage? How many visited the zebra cage? As many things like that. So for analysis to know, okay, many people visited the lion cage more than the tiger cage, for example. So they can get that kind of information. So they got this information also, these people. And in Python, when you want to, when you are working with a data, let me show you this data originally. So let me show this data originally. Let me show this data originally. Now, this is the data in this is the data collected as inputted in Excel sheet. They have it in Excel sheet. But if you want to work with Python, if you want to analyze this data, you cannot analyze this data on Excel sheet. You have to import this data on Python, and you import it as data frame, So that's what you do. And to import that as data frame, what you do is to make use of pandas. Don't forget what I said. Pandas is a package that is used for high-level performance data analysis. That's what pandas is used for. Now, if I want to import that data now from wherever I save it on my local disk on my laptop, I need to give it a name that I want to use to work with it on Python. For example, I'm saving this as travel underscore data. You can give it Europe data, give it any name you want. Travel underscore data equals to, now, the data was, the Excel was saved in CSV format. For you to import a CSV format using pandas, you have to use this function. Let me put this function for pandas. I'm not putting full pandas because we already installed pandas as PD. I didn't mean we didn't do this part, it will be pandas. But I already installed it as PD, pandas dot read underscore CSV. Read underscore CSV. Read underscore CSV. That is, so anytime you want to import any data frame, any data from your laptop, your local disk to Python notebook, this is the function that you use. So the name I want to give to that data that I showed to you in Excel is data underscore travel. You can try to give it Europe travel, summer travel, anyone you can just give it. Once you do that, equals to under brackets. Now, this thing is on my local laptop, on my local C drive, right? For me to tell pandas, for pandas to be able to access this, I have to give the path for this panda.read underscore CSV to locate that folder, that document in my drive C. I have to get the path. Don't forget, when I talk about the path, that means I have to supply the path information to this. So that if I supply the path information, this PD read underscore CSV will locate this from my C drive, go to users, go to this, my username, document this data, and get that document. This is the name of the document. Let me show you. Can you see? That's the name of the document, and to go. Once that is done, I can now say, okay, travel.get in brackets. Click to show to me. If this part is not correct, Maybe there is a capital letter or small letter somewhere. It will not work. For example, let me put document in small letter D. Okay, I think it document in small letter D. Let me see something. Okay, now this is document. I deleted O. It will tell you no such file or directory, because there is no directory, there is no folder called DC ment. So you have to be correct in putting your document part. So this now, so automatically, let me remove this part for now. So automatically it uploaded this folder onto the Python notebook. Now, if I want to look at my data that I've uploaded now, if you just put this, to show, if I put, this is the name of data, is it data underscore data, right? Can you see? It shows me from the beginning, it shows me the first five information. This is the row, and these are the column. So it shows me the first 5 row and the last 5 row. You see, this is the first traveler, visited United Kingdom, West Britain. On this date, this is the date and time. This is the latitude and longitude of the location that I visited. You see, now, if now is this information also given that there are 1,075 rows and 5 columns. The Panda was able to give me information about this, that this row that you are seeing, they have first 5 and the last 5. There are 1,759 rows, and there are 5 columns. 1, 2, 3, 4, 5. 5 columns, and there are 1,759 rows present on this. Now, as a data scientist, you may want to look at the first. Let's look at the first 10. If you want to look at there's a function called edge. Let me put travel underscore data dot edge. This is going to give me the first 5 data. I'm sorry, I'm supposed to put this. So anytime you put edge, to give you the first 5 data. If you want to see the first 10, you can now put 10 or any number. If you want to see the first 20, put travel underscore data dot edge 20, whatever. If you want to see the first 20, the first 10, the first 50, anyone, just put the number there. It will show you the first 20. Can you see? The index starts from 0 to 19. That's the first 20. Can you see that? If you are interested in looking at the first 10, it will show you the first 10. The same thing is applicable. If you want to see the last 10 or the last 20, travel underscore data dot pay. In this case, you use pay. If you don't put any number, it will give you the last 5. Can you see the last 5 information of the last 5 people that visited Europe that summer? The last 5 years visited Germany, Munich to be precise. If you want to be specific about, maybe you want to look at the last 10 individual, travel underscore data, because that is the name of our data frame, and you put 20. If you want to look at the last 20, can you see the last 20? So the last 20 people that came visited Germany and Turkey. So they visited Germany and Turkey, the last 20. So they visited Istanbul and Munich in Europe. That's where they visited. So can you see that So that's how you can use Panda to do your analysis. And apart from this, you can do a lot of, let me also show you some, you can just, okay, if you want to look at the information about country alone, you can look at information about country. All you have to do is travel underscore data, right? Dot country. Dot country. Don't forget the country is in travel underscore data, right? So I want to look at country in data, in my data. So travel dot country. Can you see? It gives me the list. So it also gives me the list of the first 5 and the last 5. If you want to, let's put if you can give us 20. No, this doesn't work for this. Let's put add and see. Add for 20. Yes. So if you want to see the first 20 of country, so the first 20 countries visited were United Kingdom and Portugal. Can you see that? So the same thing, you can also use the tail stuff as well. You can also use this tail stuff as well. You can also do tail 20, tail 5, whichever you want to do. Now, another package we can also install is what is called, we can also install, don't forget I talk about matplotlib for graphing and plotting. Import matplotlib as, you can call it MP. And you can also magic command to display matplotlib command. You can use this command, percentage matplotlib inline. Now, if you want to plot a graph, for example, now, let's say we want to plot, let's look at the latitude. Let's look at the latitude. So let's look at travel underscore data dot the latitude. Can you see the latitude? So let's look at the longitude as well. Say travel underscore the longitude. Sorry, data dot longitude. Can you see? So we can decide to plot. You can plot the longitude and latitude together against each other, and it's simple. Just put your data dot plot in bracket. So we want to decide which one do you want it to be on the x-axis, which one will be on the y-axis. We want our latitude to be on the x-axis, right? And the longitude to be on the y-axis. Now, what this style means is what type do you want it to input? We want it to be in 0, right? And we give you plot. So let's say we want it to be in this format. Can you see? Can you see how we are able to use this to do? So we are able to plot. We plot this longitude against the latitude. Can you see that? We plot the longitude against the latitude. That's what we did there. Let's see if we can do the same thing for the country. I'm not sure because the country is not a number. Let's try that anyway. Travel underscore data dot plot in bracket. Let's put our x to be equals to country. I want to try because this, and let our y equals to, let's use latitude for now. Latitude, and let's give it a If you don't put style anyway, it will work, but it will assign a line. You see, we were able to plotted the latitude with different countries. Can you see what we have? So you can decide to also give, you can give it a style. Let it style equals to, let's give it, let's put O, right? So can you see what happened? These are the people that visited. These are the latitude of people that visited UK. So they visited Turkey, Kosovo, Spain, and the rest. This is how you can use Panda frame, the Pandas package to analyze different data. You know, in this place, what I already did there is I switch. I put, you know, where here we have latitude as X and we have longitude as Y. So in this place, I put longitude as X and longitude as Y, and we plot it. And can you see when we plot, when we change it? So these are packages that you can make use of in Python. You understand? This is just an introduction to modules and packages in Python. So you can decide, you can read more about pandas and some of these ones I listed here. You understand? You can read more about them. I think that would be a nice one, at least to know. So the next class we are having, we'll be continuing with NumPy, and we'll be able to discuss as many other packages we can discuss. Do we have any question?